check. I think that's why. All right. So, pick up your colored pens. You guys have done an excellent job. Remember that measuring success can come in different forms. Having the correct answer after doing a bunch of work, that is definitely a triumph. So that's what we're looking for. But if you were not able to achieve that, there is still measures of success. Was your strategy correct? Was your strategy the best strategy and you just didn't have time to finish? Or did you finish but you realize you made just a computational error? That's still success. So after an hour, the hikers are going to be approximately 3.6 miles apart. I will take anything close to 3.6 miles because it really depends on at what point in the process you round and how much you round to. And the extension, was anyone able to complete the extension? Okay, so it comes out to 1 hour and 48 minutes. So I'll talk about the extension in a moment because I just a moment ago had an interesting conversation with one of your peers. You may have heard us talking. So let's talk about this though. Having a good visual understanding of what's happening can help a lot. This was my visual, and as I walked around, I was really impressed with a lot of people who had a very similar visual. And ultimately, we end up with this triangular shape, and so we can use that part of our toolbox, tools that work with triangles. So what approach did you take to try and find this distance right here? What tools did you use? Lori and then Janai?
Law of cosines.
You used the law of cosines. Law of cosines. Was anyone able to use a different tool? Well, I mean, that's kind of what I expected because in this instance, we don't have any cases of an angle and the side opposite it. We're looking for this distance and we have the angle opposite it, but that distance is missing. We don't have any other angles, so we can't use the law of sines, which certainly is a little bit easier to use than the law of cosines. Not that either of them are really that difficult. So the law of cosines really is what I was shooting for. But it was really understanding the situation that took the time. Are there any questions about that? Okay, now the extension, I asked, they walk for another hour, so after 2 hours, one person stops and walks to the other. How long will it take them? And one of your peers had conjectured that, well, if they were 3.6 miles apart after 1 hour, that you would just double it because now it's 2 hours. And I had to think for a moment why that doesn't work. It doesn't quite work, I think, and I'm going to have to do a little research myself, because they're not traveling at the same rate. So I don't think that they're going to continue to move apart from each other the same. It's not going to just simply double. But again, I have to go back and experiment with it to get a definitive answer, but I think that's my initial response. So I was really kind of asking you to go back and look again and extend the whole picture so that it was after 2 hours. And then I was also looking for an amount of time, so there was a little conversion in there. Are there any questions about any aspect of this? Okay, so we are still talking about the law of cosines, but another piece was Heron's area formula. I told you a quick anecdote yesterday. Heron's area formula is one of the most elegant finds, in my opinion. So I just want to briefly go over again how it works, and then we're just going to dive in and use it right away. The proof of it is pretty involved, so we're not going to go into that right now. So it's all based on something called semi-perimeter. So you have to know what we're saying when we say that. Semi-perimeter could also be thought of as half perimeter. And it's simply the perimeter around the triangle divided by 2. How do you find perimeter of any shape? Add up all the distances, and in this case, to find the half perimeter, we just divide that result by 2. Once you have that result, you're just going to plug it into the formula. You're taking the square root, and it's basically 4 numbers multiplied by each other. The semi-perimeter, then you take the semi-perimeter and subtract A from it, take the semi-perimeter and subtract B from it, take the semi-perimeter, subtract C from it, multiply all those together and take the square root. With the powerful calculator you guys have at your disposal, it's going to end up being some pretty quick calculator work. So the real idea is learning how we can use this to solve some problems. Are there any questions so far before we dive in? Okay, well, I've given you a companion today so you can have all the diagrams. So you got 1 minute to get yourself set up. Set up the diagram, read the question, and then we're going to work together. All right, so hopefully you're set up. If you're not, then just join me up here and you'll catch up when you can. Triangular plots of land are not the most common arrangement, but there are instances. So there is an idea called a traffic triangle. And so I have a diagram of one here that I've given to you as well. And we're simply going to find the area of the space inside the traffic triangle. So on mine, it's highlighted in green or colored in green. Yours is probably gray. So, and we're going to use Heron's formula, but I just want to point out that we could, if I had never taught you Heron's formula, we could take the traditional approach of finding that, the height, using maybe some trigonometry and some algebra. We could use the other formula if we had the right information, but we don't have any angles, so we can't do that formula. So enter Heron's formula. Heron's formula is based on knowing the semi-perimeter. So we need to find that, we need to find that first. And the semi-perimeter is simply half the sum of the sides. So it's half of 170 plus 240 plus 350. That can be done with mental math. We got 100, 200, and 300. That's 600, 670, 710, 760. Divided by 2. What does the semi-perimeter come out to? 380. 380. If you're baffled by what I just rattled off, all I did was I added 100, 200, and 300. And then I took the 70, and then the 40, and the 50, and added those on. That's faster than using a calculator. So we now know the semi-perimeter is 380. Anyone have any questions so far? So now we find the area. Heron's formula is just one big square root, and we take that semi-perimeter and then multiply it by the semi-perimeter minus each one of these values. So do 380 minus 170. 380 minus 170 is 210. Now do 380 minus 240. You can shout it out. 140. Now do 380 minus 350. 30. Pick up your calculator and do square root of 350 times 210 times 140 times 30. What is it? Oh, that's supposed to be 380. Sorry. Sorry. Thank you for correcting me. I said 380. I wrote 350. I have no idea why. So what does it come out to?
18,307.
Yeah, 18,307 and change. Now let's see, do we have a unit of measurement? It was yards. So area is measured in squares. We have square yards. And that is Heron's formula. Anyone have any questions about how we did that? For some of this unit of study, I would highly recommend a set of flashcards, traditional flashcards with name of a formula and the formula on the back, and just work on it. Just a couple of minutes a day, not a big deal. Are there any questions? Okay, so this is the first checkpoint for today, but it's the second one for this lesson. Did the college tour go to MIT?
Yes.
It did?
Yes.
Did you guys get to see this building?
I think
I've never been, so.
I think we have.
Yeah, we didn't know.
Okay. There are not that many triangular shaped buildings in the world. There's one in New York City. There's one at MIT. I'm sure there's plenty of them, but it's nowhere near as popular a choice as many others. So, the Landau building at MIT has these dimensions. So, my first question is, what's the area of the base? My second question is, what's the volume of the Landau building? And then the extension for my students who are able to complete A and B is, what are the angle measures of the base? When I say the angle measures of the base, just to be clear, I'm referring to what's that? Whoa. This angle here, that angle there, and that angle there. Anyone have any questions? Okay, this is independent, but I'm going to transition it from independent to team halfway through. So I'm going to put 5 minutes on the clock for you to work independently, and then we're going to switch to team. We got 5 minutes on the clock. Go. All right, let's come together. CMOs are going to share out. So we're just going to do part A to start with. So I'm just looking for the area of the base, and we're going to start with team A, B, H, E, and D. Team A, what did you guys get?
We got 18,617.
Okay, team B. Your CMO. For the area?
I got 7,650.
Okay. Team H?
18,632.5.
Okay. 18,000 plus, and you said 18,000 as well? Something like that? Okay, team E? Just for part A.
Oh, okay. He came out to 18,000, the same answers that everybody was saying. That's correct. I did something wrong. So yes.
Okay, that's fine. I appreciate that. And team D?
18,617.6.
So it comes out to somewhere about 18,618, anywhere close to that. Again, we're going to have some differences based on at what point you rounded, but with the calculators we have, should have been just pretty close. Now, volume is really not a big stretch to get the volume. All it is area times the height. So it comes out to about 1,303,260 cubic feet. And was anyone able to complete the extension? Okay, Juan, what did you guys get for the angles?
I got 87, 30, and 63.
Okay, same thing? Yeah, that was it. Comes out to approximately 30 degrees. It's like just a hair under 30, 87.7 degrees and 62.3. Juan, how did you attack the extension?
Oh, I used the law of cosine.
Yeah, the law of cosines, because we had no angles to start with. So here is Heron's formula for part A. Semi-perimeter comes out to 346. And then you see that. And it's just calculator work. Anyone have any comments or questions on this checkpoint? Okay, so that concludes, nope, we're skipping over this. That concludes today's work. the class period is not over. Your follow-up is due tomorrow by 9 a.m. and your test is on Wednesday.